Hey guys, new page 11, but not a new learning goal. So this is nice. We can keep going with this learning goal. It says, I'm going to flip this on its base because we're used to seeing isosceles triangles like that. And it helps us see that they're vertically symmetrical if we flip them on their base. So if two sides are equal, two angles are equal. And that's the isosceles triangle theorem. So I'm not planting evidence. I can actually say angle D matches angle F because of the isosceles triangle theorem. All right, something to do with the base angles. All right, so what would that mean? Well, they're essentially saying here, these two were equal. So this would force this to be equal. So let's see why. This would be EG would be shared. EG is congruent to EG. That's called reflexive, right? And I have angle side angle or angle angle side. I've got a lot of reasons why these two triangles are congruent. So triangle EDG has to be congruent to triangle EFG because of angle side or angle side angle triangle congruence, right? So anyway, it doesn't matter. This is going to be equal. This side will be their corresponding parts of congruent triangles, and those are congruent. So FG has to equal GD. And we saw that in our learning targets. If we go back, it says segments joined by midpoints of two triangles parallel or isosceles triangles being congruent. They're bringing in some of these theorems. So can we find A? The answer has to be yes, right? 3A, we said FG is equal to GD. So FG is 3A and A plus 6. So doing a little bit of magic, I'm subtracting 1A from both sides. Gives me 2A, and I still have 6 on the right. When I divide by 2 on both sides, we get 3. We can plug this in and check our work. 3 times 3 is 9. If A is 3, 3 plus 6 is also 9. That is equal to one another. So let's dive in. What were they wanting for 7? It says, what is DF? So that would be the whole thing. So if this is 9 and this is 9, then the whole thing, DG plus GF would be the whole thing DF. If this one's 9 and that one's 9, the whole thing DF would have to equal 18. What is the perimeter? Oh, no. They're saying if the perimeter of DEF is 58. So if we added up all the sides, so EF plus FD plus ED was equal to 58, what is the length of EG? So we don't know what these are, so I'm going to put X, but we know they're the same. EF and ED are the same. So I have 2 X's. And FD or DF, I flip those. Those are 18. What would our the length of what have I done here? EF, FD. Yeah, this should say FD, and it did. I just underlined it, and it looked like. And instead of FD, I'm going to call it DF, like I called it before, DF. Okay. So DF is 18. Okay, so I have 18 equal 58. If I subtract 18, I get 40. And that's 20. Okay, so what's the length of EG? Oh, those little brats. I've solved for this. It's 9, right? I'm going to have to redraw this triangle. That's 9. I solved for this. X was EF or ED, so that's 20. So what would be EG? That's this one. I'm going to call that Y. This is a little tough. I got to do Pythagorean theorem here, right? So A and B, ordering them least to greatest, A squared, B squared, C squared. 9 squared plus Y squared or B squared, doesn't matter what letter you use to hold its place, 20 squared. Subtract 81. $319. Take the square root. It looks like you get about a decimal, 17.9. So does that make sense? And I actually think it does if this was 9 and this is 20. So I'm going to say my answer is, if they want it in square root form, or about 17.9. Okay, select all the statements that describe EG. Ooh, okay, I remember doing this with like the bus that heads out. So a median. What is a median? Well, do you remember that? Oh, what was that? What was that saying? I could go back here to my formula sheet. It's like all my children always bring in peanut butter cookies. So altitudes, I think this is what it is. Altitudes make medians. I think it's something perpendicular bisectors make centroids. This is incenters. This has to be angle bisectors, right? So we have centroids, incenters, medians. There's one I'm missing, so there's something wrong with my memory tool. I've forgotten one item in my memory tool. Oh, all of my children. Yes, okay, all of my children. Let's stick an of in there. Altitudes make orthocenters. Okay, that makes so much more sense. Orthocenters. And then medians make circumcenters. Okay. Woo. So these are all my types of centers of a circle. Types of centers of a circle. Not a circle. What am I saying? Of a triangle. And sometimes they're inside, outside. Sometimes they're in the same spot. But, okay. And what did I do here? I meant to not highlight that. I meant to highlight the word orthocenter. So sorry about that. One more correction. Okay. Now I think I'm ready with this idea in hand. I might want to snapshot that and put that in my back on my notes. Okay. So back to my notes. What do we got here? I'm going to import this picture because I feel like I need it. I'm referencing it. my types of center here. Okay. So select all that apply. So would this be an altitude? Boo, splat, yes. So I'm going to pick an altitude. Would this be a median? Okay, so a median is find the center, trace to the opposite side. That's definitely the center, so I'm going to say yes to my median. Is it a perpendicular bisector? So this definitely cut that segment in half at a 90, so I'm going to say yes, perpendicular bisector. Is it an angle bisector? Well, yes, this angle E got cut in half. So yes. Angle E got cut in half. And is it a line segment? E.g., yes, it's a line segment. So I'm going to select all of them. Wow. Crazy town. Okay. Very interesting. So I'm just going to stick that here. Cool. All right, question number 9. It says, given that AD is parallel. So this symbol means parallel. So AD is parallel to EC. So we automatically know if you see a Z, if these two lines are parallel, that's going to be AIAT, alternate interior angles. These angles will be equal. We would also see this Z, and we could say these angles are going to be equal. So let's see how this plays out. They also told us this side, AD and EC, are equal, so that's given. And they're asking us to prove, we can't prove it yet, but they're wanting us to prove that these two are equal. Okay, so this is going to be a corresponding part of congruent triangle, yeah. And this is going to have to go last. This, whatever you're proving, has to go last. So 4 has to go last. Oh, boy. So I found my answer right off the bat. But let's play this out. So 3 is first. We always start with our given. So given that my information is given, so just copy that down. So we could have said right off the bat, I'm just deciding between B and C, right? So if this is given, let's follow the logic. So 2, both of them give 2 as the next step. So 2 is angle ABD has to match EBC. ABD, this one matches this one. That's vertical, right? And that's exactly what they said. Then the next one, both choices give us V. So V states angle DAB is congruent to angle ECB. DAB is congruent to ECB. That's this Z. You see that Z? So that is cut by alternate interior. Yep, that spells AIAT, alternate interior angles theorems. So at last, you've collected quite a few pieces of evidence, and you have to figure out what that evidence spells. Obviously, it has to spell angle, angle, side. ABD is congruent to CBE because our evidence spells angle, angle, and a side. Angle, an angle, and a side. That side. Okay? So last, since I've proven the triangles are equal, we can say their corresponding parts are equal. And that's what we set out to prove, that AB, which is first and middle, is congruent to CB, which is first and middle, because they're corresponding parts of congruent triangles, so they are congruent. We've done it. That's the most logical order. Question number 10, it says the figure shown below is a swing set. The supports on the swing are constructed from 2 12-foot poles connected by a brace at their midpoint. Ooh. So this is 6, that's 6, that's 6, that's 6. The distance between their base is 5. What would be the distance here? So these would be similar triangles, so it has to be half of 5, but I'll prove it to you. The mommy is 12, 12, 5. The baby here is 6, 6, and they share the angle at the top. They're also both isosceles, so they have to share the angle at the bottom. So you know these two triangles are similar, so their sides have to make the same ratio. We could put them order least to greatest. So 5, 12, and 12 on the mommy, and x, 6 and 6 on the baby. Notice how they make the ratio 1/2. We could cross multiply, and we get 12x is equal to 5 times 6. So 12x is equal to 30. And when we divide by 12 on both sides, 30 divided by 12 is exactly what I guessed, 2.5, because the baby is half the mom. See how half of 12 is 6? So half of 5 is 2.5. The length of the brace is 2.5 feet. Well done, gang. See you next time.